Okay. Good morning, all, and welcome to the third bootcamp of CSIR JIGYASA Epic Hackathon. I welcome all the esteemed panelists of the day and thank them for taking out time from their busy schedules to help out the students and give them the right direction. I also welcome all the school students, teachers, CSIR scientists, and others who have joined us online from different parts of the country. As you all might know, CSIR Jigyasa has launched EPIC program for school students on 5th January 2024, providing a platform to the budding scientists to develop novel ideas. The first two boot camps were organized on 16th January and 24th January respectively. The videos of both the boot camps are available on the Jigyasa Virtual Lab platform. Students can freely access them whenever they require. So to begin with today's session, I would first like to invite Dr. Somdata Karak, Science Communications and Outreach Officer, CSIR, Center for Cellular and Molecular Biology, CCMB, Hyderabad, to deliver the opening remarks. To brief our audience about ma'am, she's a life scientist by training. She has done her PhD in neurosciences from University of Göttingen, Germany. She then became a Teach for India Fellow in her attempt to understand the science education system in our country. She is now the Science Communication Lead at CSIR CCMB. Her work focuses on creating science content and platforms to discuss science, especially for young people. Over to you, ma'am.
Thank you very much, Raina, for the kind introduction. And good morning, everyone, for joining us today. And I hope that you are all able to attend and listen to our conversation on YouTube today. If you have any problems, please do put up a note there so that we can take care of it immediately. Now, just to bring you back to setting context for what we are here for. This is what we call as a boot camp for something called as EPIC Hackathon. And EPIC here stands for Empowering People for Innovation and Creativity. And what we have been trying to do at CSIR, and CSIR is Council for Scientific and Industrial Research. CSIR runs 37 scientific labs across the country, and we work on a plethora of different topics. It ranges from biology, like at CCMB, which is where I work, to chemistry, physics, engineering, and even policy making and science communication. And we have scientists who work at all these different scales, at all these different topics, but we see that the young people in India are still not connected with science the way we would like them to. They think of science as more like a subject that they need to study in their schools. You give exams and then you forget after the exams anything that you have studied. But that's not what we really want out of science education or with our science communication either. We would like you to think about science as something that you learn for your lifetime. You think of science as something that should become a part of your life. And your decision making in life should be informed by the science that you study, not only in schools, but also that you keep in touch with, even when you become adults as citizens of this country. So while that is the big aim that we have also realized how innovation has caught the imagination of our young people. Young people today want to innovate new things. They want to create solutions to the many problems that our country has. And that's exactly the essence of this EPIC program. And while there are many, many problems that probably one can work towards, we have identified two thematic areas for this year: health and energy. And I think none of you will doubt that these two are really the key problems that are facing all of us. And you young people will probably be the ones who will need to come up with solutions so that we together are able to create a better future for not only us, but for you all and the generations to come after that. And that really is the idea for our hackathon this year, that we try to connect all you young people with the many experts who are working in the areas of health and energy. You hear from them, you understand not only the problems that are out there, but also how are these scientists really trying to think about solving these problems? What tools are they building? What technologies are they building? And what kind of research are they doing? And you should be using that, or we hope that you will find it useful to not only come up with your ideas for this particular hackathon, but also that these will be your ladder to thinking about what you go on to do later on in your lives. So many of you probably want to become doctors, many of you want to become engineers, and that's totally fine. If you become scientists, you'll be thrilled. But if you want to become doctors, engineers, lawyers, you need to understand these problems that we have today. And you need to understand the tools that we have today as well to solve them and to ask the right questions, no matter which career trajectory you go on to take up. And this hopefully will also lead some of you to not only science, but also to become entrepreneurs using these scientific tools. So we have these all big ideas that we have in our minds, and we hope that all the young people will take advantage of this platform to make this platform better. So this platform is basically supported by CSIR's Jigyasa program. And through Jigyasa, we do loads of programs that helps connect school students with scientists. And they range from coming to see our labs, what we do in our labs, to having more intensive programs. And Epic Hackathon, I think, is really the most intensive program that we are trying to do. Why am I saying so? Is because not only we are getting these scientists almost every fortnight to come and talk to you online, we are going to, I mean, we have this platform for you to also send us your entries. And in a short while, I'll show you how you can register for this program and send us your entries. But we also, then from those entries, will be selecting some 100 of you, depending on the quality of your ideas, of course. We will be selecting you and then put you under the mentorship of some of the scientists in our labs so that you can grow your ideas further and build something which is really feasible and workable. And that is what Epic Hackathon is trying to do here. And I'll quickly share a video that will show you how you can participate in this program. Tarun, please confirm if you can see my screen.
Yes, ma'am. It's visible.
Okay. And I'm making it full slide now. All right. So I hope that you have gotten a gist of what the program is trying to do and how you can participate in this program. And with no further ado, I think I should now move on to the next session where we have three excellent experts waiting to interact with you all on the topics of One Health, clean energy, which are the two thematic areas that we expect your ideas to be on for the Epic Hackathon. And we also have an expert to tell you what innovation really means. When we say that you should be submitting innovative ideas, what really makes an innovation? What are the key aspects of making an idea to be called as innovative? So with that, I will now hand over to Raina to take the session ahead. Thanks, Raina.
Thank you so much, ma'am. Thank you so much for setting out the basis and context of the entire Jigyasa Epic program and today's sessions. So thank you so much. So moving on further to talk about our first theme, that is One Health, we have with us Dr. Pankaj Dhaka. He is from Center for One Health, Guru Angad Dev Veterinary and Animal Sciences University, Ludhiana. He is assistant professor over there. And to brief about Sir, Dr. Pankaj Dhaka is associated with research projects in the area of zoonosis, food safety, and farm biosecurity and antimicrobial resistance also. He has authored 4 books and 36 research publications in reputed journals. So, over to you.
Yeah, thank you so much. Thank you, Dr. Somdatta and Dr. Rena. Uh, Good morning, dear participants. And first of all, I want to thank to the organizer of the CSIR Jigyasa Epic Hackathon 2024 to invite me on this very important platform to share my views. And why I find this very interesting platform because here as a scientist we can share our views, and yes, I as I know most of the participants are students, and of course you can know, you can observe what we are doing as a scientist or as a academician. So again, thank you so much to the organizers. Today my topic is on One Health, and I hope as the term suggests, One Health means there must be some interconnectedness. As you know, recently we organized G20 summit, and the main theme of that summit, as our Honorable Prime Minister Shri Narendra Modi ji, he mentioned that Vasudhaiv Kutumbakam means one earth, one family, and one future. So one health is more or less the same thing. Means we must protect our animal as well as our environment to make us or to keep us healthy in a more sustainable way. So with this background, I am sharing you my today's presentation, and I will share my research, our research finding, what we are doing as a scientist. So please wait a minute. So I hope this PPT is on full screen mode. So okay, thank you. So today we will discuss what are the important applied aspect of One Health. So as I already discussed, okay, if we want to keep us healthy, we must have very good relationship with our farm animal as well as our ecosystem. So in brief, One Health is a approach. Now you might have heard this term more or less in news. This approach should be collaborative, means we need collaboration between different disciplines, and multi-sectorial means there must be different sector, of course, based on the problem what you are going to solve. And of course, if needed, it must be transdisciplinary. Means, of course, like if I will talk about the zoonoses, what are zoonoses? They are the diseases which can transmit from human to animal, or sometimes animals to humans. So we need veterinarian, we need human physician, we need, of course, ecologist, or sometimes wildlife experts. We will see. Why it is needed? Of course, most of the time we are focused on local issues, sometimes regional, national, and like in case of COVID-19, global issues. The main aim of the One Health was to apply the One Health approach is so that synergistically means all together we can give our expertise and we can get optimal health. And we must respect the interconnection between human, animal, and ecosystem health. So what are the important domains where we are working as a scientist of One Health? First of all, most important is zoonosis. As I already discussed, these are the diseases which are mainly transmitted from animals to humans. Remember, there can be many transmission pathways. Okay, it's not so easy to define the transmission pathways in one line. Pathways means how the pathogens can transmit from animals to humans. In this slide, you can see, of course, farm animals, because more or less like farmers or other occupational risk groups are more or less in contact with farm animals. Or if you are having pet, you are more or less in contact with pet animals. So they can pose high risk if they are infected. Remember, most of the time we are neglecting wildlife. Okay, that's very important, because nowadays we know, because of deforestation, rapid travel, tourism, we are coming in contact with wildlife, or sometimes our domestic animal might come in contact with the wildlife. In such scenario, there are high chances that pathogen spillover can be there from wildlife to farm animal, and from farm animals to humans, or there might be direct transmission from wildlife to humans. Apart from that, synanthropic animal, these are not the domestic, but they remain within the vicinity of humans, human habitats, like our lizard, our birds, our most important is rat. You know, rat can be the reservoir of many pathogens, as little as like leptospirosis. You might have heard the disease. Okay, this is the disease mainly spread from urine of the rat. So remember, there can be many pathways of the transmission of pathogens, zoonotic pathogens, from animals to human. Do you know that out of total infectious diseases, means the pathogens which can cause diseases, around 60% are zoonotic in nature. Means around 60% of these pathogens we get from animal contacts. That is around 6 out of 10. And out of total emerging diseases, what are emerging diseases? Means which are either new or previously which are in very less frequency, but now the frequency or incidence of that diseases are increasing. Out of the emerging diseases, around 75% are zoonotic in nature. That is, out of four, three diseases are zoonotic in nature. So now you can appreciate why zoonoses are important, why it is really important to address this concern, at least in the group which are at risk. So if you will see the pathogen under transition, of course, there is very long list which are emerging, starting from our COVID-19, and in past 1 or 2 years, you might have heard of some of the sporadic outbreaks of Nipah virus, especially in Kerala. Then, yeah, in 2014, you might have heard about Ebola, very dangerous disease, mortality rate, even in some of the outbreaks, above 70%, and many more. Okay, this is just list so that you can appreciate that these diseases are coming up. These are in emerging in nature. And unfortunately, we could have controlled very less disease. Only single disease what we have been able to eradicate it, that is smallpox. Of course, we are controlling many other important diseases like guinea worm, yaws, polio also near to be eradicated. And yes, we are having good vaccines against measles, leprosy, and tetanus. But we must be aware, okay, these pathogens are evolving, they are continuously mutating, and they are trying to adjust to the new host. So this is really dangerous, especially the viruses. And if I will talk about viruses, more specific, the RNA viruses, because they can mutate very fast. So we don't know what can be the next disease. Like during COVID-19, we were not knowing this is going to come. So as very rightly WHO recently, the DG of the WHO recently mm, told to the press media that be prepared for disease X. X means any unknown disease, which we don't know. What are the various factors, okay, for the emergence of disease? Of course, deforestation, as I told, if you will go for deforestation or if you are harming the ecosystem, directly or indirectly, there are huge chances that pathogens may spill over. Globalization, of course, we are living in globalized world, and our contact time is very low, and the contact period is of course very high, more or less. Then population growth, because as we are growing, we need more and more animal source of protein. For that, we need animal husbandry. We will discuss about the food safety issues. So what we do? So basically, I'm veterinary epidemiologist. Okay, so epidemiology is the story of disease. We used to find how the disease spread, what are the important risk factor, who means I will describe 5 W's. Okay, that's very important to understand for to discuss anything in epidemiological context. Who means what are the person or animals which are getting affected from a particular disease. What means what is the frequency, means how many humans affected from such and such zoonosis, or how many animals get affected from such and such diseases. Then next is where. Where is to describe the geographical distribution, whether the disease is regional, localized, whether it is of national importance, or whether it might be of international importance. For example, COVID-19 is having across the globe distribution. When again very important temporal trends, means what is the time period of the peak epidemics, okay, or outbreaks. As we know, like some of the diseases like chikungunya and malaria, okay, most of the time they used to have seasonal distribution, pre-monsoon, post-monsoon period, okay, more or less. So we need to understand the temporal trend of the disease also. And why? Again, very important. What are the risk factors? Because we need to target the risk group, then only we can frame the control strategy or prevention and control maps. So remember why it is difficult to address the zoonosis. The zoonosis can have very vast host range. Here I'm providing you one very important zoonosis, that is brucellosis. Okay, this is mainly disease. The at-risk population are the farmers or farming community, because they are having direct contact with the animals, okay, farm animals, and it can affect many animals. Okay, you can see in the given figure. So the more broad the host range, the more difficult to control the disease. So most of the time we used to study what are the important hosts for a particular disease in the study region. Then our second aim used to be what is the important transmission pathways, or what are the important risk factors. For example, in case of brucellosis, the pathogen can transmit mainly through abortions. During abortion, there used to be very high number of shedding of the pathogens in the aborted fetus or biological material. So if farmer is coming in direct contact with that contaminated fetus or material, there is very high chance of disease transmission, pathogen transmission, sorry. And yes, for urban consumers also, if you are consuming unpasteurized milk or milk product, means if you are just drinking raw milk, sometimes in society there is misconception also. Like when we used to visit the villages, many farmers used to say that raw milk is good, more good for health. If you will boil the milk, it will destroy the nutrient content. So that's not true, because if you won't boil the milk, there are chances if some pathogen is there in raw milk, you can get that pathogen. So please remember that one. So we used to address such type of risk factor, risk practices. Always remember, zoonosis can vary with their socio-economic consequences. Best example I used to cite like rabies. There is much awareness about the diseases. This disease, rabies, used to transmit from mainly from dogs, 97, or sometimes cat. Okay, the mode of transmission is bite. But what is the unfortunate thing? If you are getting the rabies, there are high chances that it's 100% fatal. If you are not taking the treatment, that is proper washing of your wound and followed by vaccination protocol, then unfortunately the disease is 100% fatal, means there is no chance of surviving. Some of the diseases, as I discussed about the brucellosis, there can be high economic cost in terms of production, because the disease mainly affect the animals, their production capacity. So in one of our research in our center, we find there is huge economic loss. So, and it's very, very important to address the economic loss of the disease so that the policymakers can get a view why it is important to address. Of course, if the socioeconomic loss is high, we need to prioritize that disease. Same cost benefit analysis. If, for example, if I am having 4 or 5 control and prevention options, which option is the best? We need to target that one. And again, we need to carry out the cost benefit analysis. That is, for example, if I am going for vaccination, what will be the total cost of that program and what benefit I will get? For example, in case of endemic diseases which are largely prevalent in any region, we used to go for vaccination because it can generate the herd immunity, as you might have heard during COVID-19. Okay, that's why we try to vaccinated full population. Okay, to get the herd immunity. That's very, very important. So other our work is to prioritize the disease. For example, in Punjab, we are having many zoonoses. For example, 15, 20 important zoonoses. Which one is very important to target? Which one is the second one? That is, you need to prioritize it. Okay, why it is important? So that we can make the policies, robust policies, and we can pay more attention to the top priority zoonoses. So that's very important. For example, we carried out this exercise and we find, of course, brucellosis is number one, number two is rabies, and number three is anthrax. So and so. And how we prioritize based on many factors, and starting from like how much it can cause disease to humans, how much severity in animals, what are the mode of transmission, how prevalent the disease is. So there are many factors. Again, very important, we used to work on developing the surveillance system. That's very, very important. Surveillance means we need to continue monitoring the zoonosis. Best example I can cite here, like we are having very robust weather monitoring system. We know like tomorrow what are the percentage of rain in this region. But unfortunately, because the diseases involve many factors, okay, not only the physical data, there are involvement of biological data also. So we can't be sure, 100% sure this outbreak will happen this time, but of course we can find some of the risk factors and we can make early warning systems. Of course, our institute is also involved in surveillance system of some of the important zoonoses. Second component is the food safety. Always remember, food safety remains very important issues, especially in developing countries, mainly because of unhygienic practices and less consumer awareness. So this is WHO data. 1 out of 10 people fall ill because of these pathogens. Most of the time, of course, they are not very dangerous pathogens, but they can cause huge socioeconomic losses. How? For example, if you are getting ill due to food poisoning, you are going to miss your schools for 4 5 days. So that such type of losses we use to calculate by one metric, that is DALY. disability associated life years. So it's very, very important to quantify the losses. So remember, so how we can address? First and foremost, because as a veterinarian, I'm more concerned about food of animal origin. First of first first of all, if your animals are healthy, of course you will get healthy food. Always remember. So we must focus on healthy animal products, and how we can focus by farm biosecurity. It is nothing but we are securing our farm from pathogens. Means we are securing our farm from the introduction, establishment, and spread of the pathogens within and outside the farm. So farm biosecurity is a concept which involves many parameters. Where, for example, if you are bringing animals to your farm, you must keep them for quarantine. Okay, don't mix that animals. Okay, these are some one of the examples. Like you must go for cleaning and disinfectant. Okay, so again, we used to target what are the important microbial contamination in food of animal origin. For example, recently we published two papers like we characterize our chicken eggs for some of the pathogens, and even we find some of the pathogens are having resistance towards the antimicrobials. We will discuss what are antimicrobials. And second, for example, aflatoxins. Aflatoxins, what are aflatoxins? I hope most of you know, like these are the fungus. Okay, animals get these fungus through feed, what they eat. And if your feed is having aflatoxins, the animal can excrete aflatoxin M1 in milk. Generally, they used to get aflatoxin B1 through feed, and they used to convert it in M1, and through milk they can excrete this aflatoxin. And of course, this is quite hazardous for your health. So again, we used to analyze the risk. How much risk is there? For example, if one microbe is having so much prevalence, what is the risk of that microbes to affect the population, given population? Then we used to carry out the outbreak investigation. If some outbreak is there due to foodborne pathogens, we used to carry out the investigation. Main objectives used to be like timely response and communication. Communication is really very important. We need to communicate to the stakeholders. Then, of course, thorough epidemiological investigation, trace backing, and environmental assessment. Then consumer awareness, hygiene, preparedness throughout the production chain. Again, very important HACCP concept, that is hazard analysis and critical control points. This means like through the production to the consumer, we must maintain strict hygiene and control measures to prevent the introduction of the pathogens. Then, of course, we must know our food safety regulations at global level, like Codex Alimentarius, as well as in our national level, that is FSSAI. Third, very important component is antimicrobial resistance. Hope you know this is much debated topic. Very, very important to understand. What is AMR? So generally we used to abbreviate it AMR. When our microbes like bacteria, virus, fungi, and parasites are no longer respond to the available medicines. Okay, so it's very, very dangerous, not only for humans but for our animals also. Why we are discussing AMR? One of very recent report estimated that in 2020 around 1.3 million people died, and it has been forecasted by various models like by 2050 there can be around 10 million deaths if we are not controlling this scenario. So it's very, very important to address. In this infographics, you can see in 2020, if only this month people are there, one people represent 1 lakh unit. Okay, in 2050, it is going to so much. So what is the role of animal husbandry? Remember, 80% of the antimicrobials are we are using in animal husbandry, either directly for treatment purpose or maybe for growth promoters or for prophylactic purpose, means to prevent the disease. So this is really very important issues. And remember, if any resistant bugs is there, if any resistant pathogen is there, it can affect anyone. Antibiotics, bias of available data, yes, because lack of good surveillance system. Surveillance system means over the time period. Most of the time we used to go collect the data, that is cross-sectional study. But to get exact picture, we must have good surveillance system throughout the year. Then data sharing issues and duplications of data. So these are some of the concerns. Last component, environmental health. It's very, very important because it is impacting our water and food supply. Change in vector ecology, we know, like already I have discussed, like chikungunya and malaria or dengue. These are the pathogens, okay, which generally get transmitted through mosquito bite, and of course the proliferation and replication of the mosquito depend on over ecological situations. For example, if you are not keeping your surrounding clean, there are high chances of mosquito proliferation. Increased allergens, severe weather events like drought, floods, air pollution. Of course, in most of the region, especially northern part of the India, we are facing, okay, especially during winter season because of many factors. Okay, so last, very important, biodiversity loss. So why biodiversity is important? Just I will explain. Mm, for example, if one pathogen is having many hosts, okay, so it is known as dilution effect. Means it can accommodate in many hosts, okay, and there are very less chance it will come in contact with animal or human directly. So decreasing regulating services, buffering zoonotic transfer. So it's very important. If you are if you are not preserving your biodiversity, you are decreasing the buffering of the zoonotic transfer. So most of the times, like bushmeat and wet market trades, there are high chances of transmission of such pathogens, even some of the novel pathogens to the humans, and they can be very dangerous. And of course, if you are destroying your ecosystems, there will be decreased availability of water and other very important services, which can compromise your hygiene and treatment. So that's again important part. So, with this, I'm just concluding my talk. We need to strengthen the One Health framework. We need to coordinate, collaborate, and very important to communicate our findings. That's for that only we are here on this platform. We need to communicate to our community, to risk groups, to our stakeholders. That's very important. So, like some of the global agencies which are working in One Health, like WHO, FAO, World Organization of Animal Health, UNEP. Okay, they are coming together to address this many of the issues like zoonosis, AMR, climate change. So we need multi-sectoral approach. As in my opening sentences, I discussed like in G20, our Prime Minister very rightly suggests one earth, one health. We must work together. Government of India is also doing many good works in collaborations. We are having many good projects in collaborations to address many of the issues in One Health framework. We are having National Standing Committee on Zoonosis. NCDC is doing intersectoral work. ICMR, ICR is collaborating. And more recently, our animal husbandry ministers launched, that is APPI, that is Animal Pandemic Preparedness Initiatives, and Good Surveillance System for Animal Health System Support for One Health. Similarly, in human sectors, they launched integrated health information platforms to monitor, to carry out good surveillance, strong, robust surveillance for 33 diseases. Again, Government of India allocated the budget for National Institute of One Health, which is located in Nagpur. The work has been started to strengthen it. So remember, we used to observe the One Health Day on November 3rd, and you can find very good quotes on COVID-19, which I find very fascinating. The vaccine for COVID-19 was natural habitat because we destroyed our ecosystem. And of course, there are theories like directly or indirectly the virus spread through bats. Of course, other theories like because of lab leakage and all also there. But as epidemiologists, we think that virus get transferred through some host, maybe bat. And this pandemic is a great example of how badly we have treated the nature. So thank you so much for your kind attention. And if you need any help or if you are having any queries, please feel free to contact me anytime on this through this email address. So thank you so much. Thank you so much, everyone, participants as well as organizers. Thank you.
Thank you so much, sir, for your insightful talk. And we are really sorry for a technical issue at our end, due to which live streaming has stopped on YouTube. And I don't know whether it has started again. I think it has started again, but I'm not yet sure. So we have been recording this meeting, the time it stopped, and we will be uploading the recorded video on the YouTube. So the speakers, you are requested. We will So we will come back to you in case there are any queries. So right now, because live streaming has stopped, we are not available with any queries of the students till now. So that's the status as of now. If we get any queries from any students, we'll get in touch with you, sir. Thank you so much. Yes.
Sorry, ma'am, I think you are not clearly audible.
Sir, I said the live streaming had stopped in between. So we recorded the entire meeting, although it had gone live right now, but the streaming is stopped in between. So we are not updated with the students' queries. We will upload the recorded video there on the YouTube. If the queries come at that time, we'll come back to you with the queries of the students, sir. That's what I said. I hope I'm clearly audible.
Yes, Raina, you are very clear. I think it's just the connection problem at Pankaj's end. I think we can proceed with the program.
Okay. So moving further, I would like to call upon Dr. Pavitra Nayak, leader, Tata Institute of Fundamental Research, Hyderabad. He will be speaking on the second theme of the hackathon, Clean and Green Energy, to introduce our audience.
Let's show that there is this much of more.
To introduce our audience to Sir, he did his PhD.
They have to understand why they are paying for the facilitation. And they will also ask when you are doing a facilitation.
So he did his PhD from Tata Institute of Fundamental Research, Mumbai, and postdoctoral from Weizmann Institute of Sciences, Israel, and University of Oxford, UK. His research interests lie in the area of developing soft semiconductors and optoelectronic devices and has around 86 publications in review journals to his name. He has been awarded certain prestigious awards like Swarna Jayanti Fellowship, Infosys TIFR Research Fellowship, Smart Solar UK Award, Marie Curie Fellowship, and Dean of Faculty Fellowship, Weizmann Institute of Sciences. Over to you, sir.
Thank you, Raina. And am I audible? Just give me a thumbs up if you guys can hear me.
Yes, sir, you are audible.
Okay, yeah, good. Thanks. Thanks for the Jigyasa team at CSIR, and particularly Somdatta for this invitation. So I'm going to start my presentation. Okay, let's see that if it goes. Okay. You guys can see my slide?
Yes, sir.
Okay, okay, thank you. So I gave a title, a very generic title to my talk, and it says, let's move to the sunny side. So before I go to the main topic, I would start with a small story, and it's a story of humankind. So we as a species love to use the external source of energy for our own comfort. And it all started with the discovery of how to use fire. And back then, it was a necessity. And as a species, we have been evolving. So is our energy need. And we started from here. Now, we have come up to this point. Back then, that was the necessity. Now, this is the necessity here. So in the course of time, the amount of energy that we're consuming for our own comfort has been increasing. And as a species, our number on this planet has also been increasing, right? And because of that, we are using more and more energy, and mostly fossil fuel-based energy. And if you look at what are the projections that we might be having in 2040, we might be using 20 billion ton oil equivalent of energy, right? And you can see that if we use that thing, how much carbon dioxide emission that we can have, and particularly if you take India as a growing economy, what would be its contribution towards the carbon dioxide emission? I think all my audience know what would be the effect of a huge amount of carbon dioxide in the environment, right? The effect is already being seen there, right? If you look at the satellite pictures of the polar ice cover, and this is the picture taken in 1979, and this is the picture taken around the same time in the year 2020, and you can clearly see that the polar cap here is melting, and this is a graph that shows that how much polar cap of ice that you're losing over a period of time. If this continues, then all our coastal cities will be gone, and there will be a lot of ecological effect also associated with that thing. So there is a need for clean energy, right? So if you look at the history, when there is a problem, science and technology has provided the solutions to that. And I would like to give one example. Such example is that if you look at this picture is taken in the year 1900, and this picture is from Fifth Avenue, New York City. And you can see that on the street, it's only horse-driven cars. Now, the horse-driven cars created a huge problem on the roads because of the horse manure, dead horses, and the traffic congestion. This was a huge problem then. But then science and technology come up with a beautiful solution, and that's the internal combustion engine. Now, within 13 years, it is the same street, and the picture again taken. I can see that you hardly see any horse-driven car on the street. It's all automobiles on the street, and it was a solution then. But now we know that this is a problem now because it produces a lot of carbon dioxide, and this is not good for our planet. Then what's the solution? Well, like our ancestors, we have to look up to the sky for the help, and that is actually help. What's that? It's our nearest star, our sun, and it's a thermo nuclear reactor there. And the amount of energy that it produces enormous. A tiny fraction of that energy reaches us, but that's more than sufficient, right? If you look at the amount of solar radiation that comes to Earth, is something around 2 lakh terawatt. And we need actually 20 terawatt of energy. And if you do a back of the envelope calculation, you'll find that we are getting 10,000 times more than what we need. So in other words, in 1 hour of sun energy, we can fulfill the year's need. And the question is how to do that. And the answer is that you have to convert the solar energy into some useful form of energy that we do. If we look at it, since our civilization started to begin, we start to use the sun for some things like drying clothes outside, drying cars outside, and use it. But the best thing to use that if you convert the solar energy into electricity. Now, how to do that thing? You need to come up with a device that converts the solar energy. So basically, sun's energy comes to Earth in forms of electromagnetic radiation, or you can say that it's simply light, right? Now, the lights are consist of photons, and each photon has certain energy. What you need to do is that you capture the photon by some means, and in that material, you take one electron to a slightly higher energetic state, right? And you allow the electron to go in only one direction, right? So basically, you have to create a flow of electron. You have to flow the electron in a particular direction using something, right? And that you have to come up with. And scientists have come up with using semiconductors. Now, semiconductor, if I want to give one example, is silicon is a good example of semiconductors. Now, if you take a matrix of silicon, right, where the silicons are connected with each other, and you introduce another hetero element there, namely phosphorus there, you get a free electron in the system. And similarly, if we introduce boron into the system, you will find a less electronless, right, or we call the counterpart of electron as hole there. And this is called as the N-type semiconductor, and this is called as the P-type semiconductor. Now, when you bring one N-type semiconductor to a P-type semiconductor, you can see that I just represented the electrons as these field circles, and the P-type are the empty circles, right? So the concentration of electrons are here high, and the concentration of holes are here quite high. When you bring them together, what will happen? The electrons would start to move in this direction, and the holes will try to move in this direction. When you do that thing, you create an electric field here. That means it's like a valve here, right? Now, any electron that you create here, that would come in only in this direction, because these are like the marble balls. It comes in this direction, right? If you create here, it can't go there because it's an off-in process, right? So you have created a flow of electron, right? Now, to generate electricity, right, power, you know that it's a product of voltage and current, right? So the flow of electron would only give you current, but you need the voltage, right? Like a battery, you need to create a potential difference. Now, how do the solar cells create this potential difference in a cell? So you can think of the solar cell has two levels, right? You come up with a photon, and then you take one electron from this state to this state. That's possible because the energy is consumed to take this electron from here to here. Now, so this process is very fast, but coming back, the electron has to take a kind of processes that to come down. It's a slightly slow process, so that you can say that this is a ladder there, it takes some time things to come out, right? But if you have created a valve like this, right, a slope like this thing, before it comes down, it would like to go and start to accumulate on this side. So if more and more photons comes, then more and more electrons are getting accumulated at that end. So you see how the number of electrons here has increased, right? And that gives a voltage difference because you have more electrons at one end compared to the other one. And that gives a voltage difference. And that gives the voltage to a solar cell. So you create a voltage difference and you allow some of the electrons to come in this way, right? And that gives the flow of electrons. So a flow of electrons, that's current. And then you maintain some potential difference, that voltage, your voltage and current product gives you electrical power out, right? When we understood the semiconductor point of view, I can give you another analogy of how a solar cell works. A solar cell is nothing but a leaky bucket, and the leaks are due to some fundamental physics problems there, right? So that you can't avoid. So basically, what you have to do is that you have to collect raindrops, right? So raindrops are more like the photons that are coming from the sun, right? What you need to do is that you have to collect those things and you have to fill this to a certain level, right? So because of the leak, you never get into fill it completely, right? But you still maintain some height of the water level here. Then what you need is that, right? If you have more leaks, then you will even come down. Now what you need is that you slightly open it here and you allow some of the waters to come out, and then you can allow water to run it. So this is a working solar cell model. Okay. So the solar cells are here, right? It collects the photons, it builds up the potential energy, and you use some of these things to run it, right? And the solar cell research, what I call it, is this nothing but finding a right size of bucket and fixing all the holes there. And that's what we have been doing it. Right? So what is the first solar cell that are coming to be? So it actually spin up from the semiconductor industry. So the first practical photovoltaic cell came in 1954. It is something around 6% efficiency. That means that if it is 100 watt, so 100 milliwatt per centimeter square is the solar energy, it's only get the 6 milliwatt that is being converted into electrical energy, right? So this is first practical things that came in 6%, and that time also it finds its application in powering the telegraph poles. But these things are damn expensive then, so it never find any practical applications in the day-to-day life. It has very niche applications like in telegraphs or when the satellites come into picture, that's become part of the satellites, because there you don't care about the cost. So how it is made? It uses a huge amount of energy to produce silicon, because you produce that from silicon oxide and carbon, right? Basically, you have to burn silicon oxide in presence of carbon to get only silicon, right? And you know that what is the purity level that one needs for electronic application? It's called the 9N, the 7N. That means 99 point followed by 5 nines. That's the purity that's needed. That's why things are damn costly there, right? But for solar cells, you can still manage with 5N. So it means you take these silicons, then you melt it, then you make ingot, so you can cut it. You can cut it like a loaf of bread, and then you get wafers, and you can make solar cells. Now the final product looks like this in a solar cell, right? It has multiple layers, and it works the way I showed there. So basically, you create a valve here to separate the electron and holes and give it a path to go there, right? So this is a very energy consuming process. Now, people have also looked at different kind of materials for solar cell application, and you can see that this chart shows all different kind of solar cell things that are currently being developed. But there is one class that's called the emerging class of PV. That means these are still under development, and we think that one day they will come to the market and will make this clean energy much cheaper. Because at the end of the day, the economics plays a big role, right? The clean energy that you produce from solar cell should be competitive, from the electricity generated by, burning coal or gas. So this is one area that our lab are working, and many other groups in the world have been working there. And one class of material that has got the attention is called the perovskite materials. Which are a generic formula, like, it has a typical crystal structure and has a generic formula like ABX3. I'll show that what is that, right? So the A can be a monocatalysis system, like it can be cesium or can be organic based salt cation, and B can be metal like tin or lead, and the X are like iodide, bromide, or chloride kind of things, right? And you can have mix and match. You can have different composition of A, B, X, right? And if you do that, I think you can actually make semiconductors with different properties. Now, why that's so fascinating? Because the way we prepare the materials here, right? How do you prepare a perovskite? First, you have to know actually what is the cell architecture, and then you'll see that how we can prepare it. Okay? So the perovskite solar cell is nothing but more like a sandwich. Okay, so it's a sandwich, not like this, but a sandwich of different electronic materials. So basically, you take a transparent electrode, right? It's like your touchscreen material, right? And then you put different layers, layer by layer, and then you put a metal electrode on the top to complete the cell. Now, how it is made? So if somebody wants to make a perovskite-based solar cell, one has to find two salts, one lead salt and one organic salt. And then you take organic solvent that makes these things soluble. Then you find a formulation that you can do. And then what you do then is make dosa or uttapam, whatever you call it. So basically, you take the solution, the perovskite solution, and you put that on a spinning disc. So it rotates, right? And then you heat a little bit something around 100 to 150 degrees centigrade, and the material is ready. Compared to silicon, where it have to go to like 1000 degrees centigrade, Here you can do it in 100 and 150 degrees centigrade. And the material is as good as silicon in terms of its performance, right? If you don't like that, then you can also prepare it in a slightly different way. Like you create a box and you take out most of the air out of the box, and then you heat the organic salt and the lead salt, and you allow it to get deposited onto a substrate. And with a little bit of heating, this substrate would have the perovskite thin film, right? Then you can put the other layers to complete it. So if you look at that, how thin these cells, and it's amazing. It's like 0.7 micron, the total thickness of the cell. It is like if you to have a comparison, your hair is something around 10 to 20 micron, right? And it is even thinner than all these activities, is thinner than that, right? How it works? It works in a very simple way. So when the photon comes, it takes the electron to its higher state. But we put a layer that doesn't allow the electron go in this direction. It only allows the electron go in this direction. And the holes, which are like bubbles in water, so it can't go in this direction, it only goes in this direction. This is how we give directionality to the electron and hole in this kind of cells. It's called the double heterojunction solar cell. That's a bit of technical thing, I don't get into that thing, but this is how it works, right? But the problem with these kind of materials are they're not very stable. Like if you expose that to dampness or heat, they degrade very fast. They work fine, but the stability is not so great. So in our group, what we have been doing is that we have been trying to understand what causes the degradation in these materials and how to make it better. So one such thing that we have found, it's a very simple chemistry. We found that if you look at this compound and if you add that to the perovskite formulation, it makes the perovskite composition very stable in our perovskite condition. That's one thing that we have achieved, and we have many other tricks to make it more stable, and that's currently we have been working on that. The another class of material that we work on is called the organic electronics. Okay, or organic photovoltaics are part of this organic electronics. So basically, this is like a carbon hydrogen based material or some metal present in the organic framework, right? Or it could be purely carbon based material, and the structure is pretty similar to what I've shown in perovskite. So this is another class of materials that you work on, and the beauty of this material is that these are flexible things, right? You can do it a roll-to-roll printing kind of thing. Means that's the way the newspapers get printed, right? You can do a mass production, and you can put it anywhere because they are flexible and lightweight. You can put it anywhere you like to do. Unlike silicon, which pretty rigid, these things are very flexible and you can put it wherever you want. This is another class of material that people have been working on. Now, these class of materials have a little problem compared to the inorganic things because they don't carry the charge carriers that efficiently. So pretty recently, we have come up with materials that boost this charge carrying capacity of this organic semiconductor, and this being developed in Hyderabad, in TIFR Hyderabad, and this has now reduced the cost of these things that are being used to boost the performance of solar cells. So this is another area of research that people have been actively looking at it, that they taking this organic material that you can design in your lab, you can prepare it, how to make it work better in solar cells. Right? Now, the sun is not monochromatic. If you use the silicon solar cell, it only takes only a fraction of light into account because of this thing. The sun gives light in all kind of radiation because it's a black hole, right? And you know that who has done this thing first time? Isaac Newton. So you just prism and see that the white light, perceived white light from the sun has consist of many colors, right? And because of that, it has a problem because the energy content of the photons are not the same. So if the energy is less, then it will just go through that semiconducting material because it doesn't have enough energy to take it to the eccentric state. But if you come up with too much energy also, it will take, but it will dump a lot of energy as heat. So that's also a loss. To overcome that thing, people are now making something called a tandem solar cell. So basically, you take two different kind of materials or three different kind of materials, to observe photons with different energy content. So basically, you put two materials. So one material would take care of the photon, which has high energy, and one material that would have a low energy content. And ultimately, they harvest both kind of photons, and the overall efficiency goes up. So people are now trying to put perovskite on silicon solar cells to boost its performance. So that's a new class of material that's a new kinds of devices that's coming up, and that's the future there, right? And people are already reaching 33% efficiency with this tandem structure, right? Now I said about it has to be cost effective. It has to compete with the energy cost from the fossil fuels, and luckily this price has been on the downward trend. Like in 1977, this was like $76 per watt of energy that produced. Now it have come down to 30 cents, and now things are still reducing further and further. And now, if you want to have a comparison that how much it is with respect to coal and gas, you see that in many places, if you are like a place like India where the sunlight is abundant, right, you can get things in less than 3 US cents per kilowatt hour. Like here, if you talk to any solar cell utility company, now you can get this solar power in like 4 rupees per unit, where if you buy directly from the grid, if you're a commercial establishment, you have to pay 7 or 8 rupees per unit. So that's the kind of competition that the solar modules are giving nowadays. It's all about that how much investment that one need to have. Now, government is coming up with a huge scale deployment of rooftop solar cells, and so that people can generate the clean energy for the household uses, because the cost have gone down, and with the new technologies that in the horizon, the cost would come further down. This is all about the mass production. Now the supply line is pretty limited, because to make silicon-based solar cell, you need a huge investment to make solar cell. But the new technologies would need less investment and faster production. So that would make things much easier in the future. Now the solar cell has a lot of socio-economic impacts that you can see that, like in the remote places where still the grid connectivity is a problem. Now government is putting a lot of solar cell based mini power plants to supply electricity in the remote areas. As you all also know that the solar cells also power satellites. So you can see that the diverse applications of solar cells for humankind. Now in India, big solar farms are also coming up, and particularly in our desert areas in Gujarat or in Rajasthan. And to give you a picture that how it is happening, this is a picture of a large solar plant in 2016. And you see that by the year 2020, the area that they have covered huge. So these are barren lands there, right? So easily to get the land there, and the sun light is available most of the time of the year. So these are the best places to harvest sunlight. And government and private entities are now putting a lot of effort to setting up solar cell parks there to generate green energy. So I can say that we are in a right path, and we are actually getting more and more into the sunny side with the right kind of technology on our side, and also the policies. Thank you very much for your time and listening.
Thank you so much, sir. Thank you so much for your talk on the green energy. In case there are queries on the side, we'll get in touch with you, sir.
No problem.
Thank you, sir. Now I would like to invite Ms. Deepti Ravula, Chief Executive Officer, VHub. VHub is India's first and only state-led incubator for women entrepreneurs by the government of Telangana, who will be giving an overview on the S&T innovation and entrepreneurship. To brief about ma'am, she's an Aspen Fellow, Chevening Fellow at the University of Oxford, and an electronics engineer with over 15 years of experience, including positions at companies such as Palm, Nokia, and Qualcomm. She served as a joint director for electronics and semiconductors for the state of Telangana before taking the position at VHub to foster women's entrepreneurship. Over to you, ma'am.
Good afternoon. It's a pleasure and honor being here. So I'll keep my comments a little bit brief. So the topic and the conversation we are having is, or the topic that was given to me was about innovation. So I'll just touch upon the student innovation aspects of what we do at VHub. To start out with, Pavitra sir, it was a very insightful session, and I really enjoyed listening to the process, because it's been a while that I was part of such a nice description and a process, and it was very in-depth. Thank you for that. Coming down to the work we do, when we talk about innovation among students at VHub, I'll start out with VHub and then we'll go a little bit back, right? So at VHub, we do programs for students to encourage them to engage with STEM a little bit more. The reason we do this is not to make sure that they go on and become engineers and doctors and anything related to tech, but the fact is, as they go on and grow in their life, they are able to enjoy and use STEM as a catalyst to achieve the passion that they want to achieve. So that is the reason why we do this. And so far we've worked with more than 1,235 students, and we worked with them on hands-on on creating a ham radio. So they actually built a ham radio from scratch. They also did work on advanced robotics. They did work on, they made drones, they flew drones. They actually made rockets, which actually many of them, fired off well, but some of them went in a different direction. So the whole point of what we do the work we do at VHub when it comes to girls in STEM or anything related to innovation is to make sure that, a lot of young people understand that, STEM is a great catalyst for you to scale and reach your goals faster, to keep the curiosity going and make sure that, science is fun. So that is what we do. Coming down to the topic on hands about innovation and all that. Okay. So given that we are working with, I've been told that a lot of the audience here is school students. Okay, so when you are in school, there is a lot of, and then obviously you want to go into college and then you want to pursue your stream that you want to choose. But when it comes to this, a lot of us think that getting more certificates and participating in more activities and getting a recognition for it is the reason why we need to participate in everything. So I want to tell you guys that it really doesn't yield a lot of results having 100 certificates and not having the appetite or the interest in the fields that you have certificates in. It's not going to yield a lot of outcomes. A simple example for that is, let's say we are participating in an entrepreneurship conference. We go there for 2-3 days, we participate in it, and then we get a certificate. But what is the point when tomorrow somebody says, okay, you were at this conference, what are the 3 takeaways for you? And if you are really not there, but you have a certificate to prove that you're there, how is it going to take you forward? So never do anything just for the sake of a paper. So that is the first thing I'd like to tell you. Second thing is, when we talk about innovation and entrepreneurship, a lot of us think that, we have the most innovative idea, and that is most often than not, it is true. But the challenge that happens is, when your innovative idea doesn't have enough background research and enough hands-on work, then it stays an idea. It does not translate into a product. So innovative idea plus expertise or effort that you put in to translate that innovative idea is what leads to an innovation. Otherwise, we oftentimes think that innovative idea is equal to innovation. It is not that. There is a small component that is often missing between an innovative idea and innovation, which is research, execution, and outcomes. If you have these 3, that is when your innovative idea becomes an innovation. And the third important thing, you may think that, but we are kids. We know we are in school. We may not have a lot of resources. And that is where I think as a kid, even many centuries ago, if I may say, as a kid, even I had the same issue. But now, with the kind of opportunities that teachers and we are actually on one of these forums which is showcasing how if you have any question or a query, which is a curious query, how many people are there to support you? Whenever you have a question, you have a query, or when you want to go forward and create something, you have an entire plethora of support system that exists, be it your teachers, be it your peers, be it actually the internet, be it mentors who are there to support you and scale you. So these are a few things that are already there for you to go from innovation and wanting to become innovators to actually becoming innovators. And now, let me give you a few examples, right? You may think that, okay, she's saying that everything is easy, we just need to work a little bit hard, things like that. So let me give you a little bit of an example. And this is an example that I'm going to take up from our own Girls in STEM cohort. So we run an active Girls in STEM cohort, and we had children who actually came to us as part of Girls in STEM. They came to learn about, I think what did they learn? 3D printing. They came to learn 3D printing and they also learned a little bit on augmented reality. And these are children who are from 9th and 8th grade. They came to BHub, they learned these courses, they even got a certificate. But as they were learning, they realized that they had access to computers, they had digital skills, they had so much more. So with this having come here, they also became a little bit entrepreneurial in thinking. We are privileged enough to have access to all these tools, but there are a lot of government schools around our own school, a little bit farther away, where a lot of children do not have access to digital school skills. They don't know how to use the power of technology. They don't know how to kind of like write an email even. So with that, they came to us and said that we want to actually start a skilling academy focused on government school children. And that is where an idea was. It is not a new idea. It is not something that nobody has done before. It is not an idea that we have not heard from many children. But the thing that was different between the two children that came to us with this idea and a lot of other adults also who came to us with the idea is that when these kids came to us, they were very clear with who their target market was. They were very clear which villages they wanted to target. They were very clear in highlighting the fact that, what is the time duration in which they want to complete. And they were also very, very clear in how they wanted to do it in parallel with their academic schedule. So these 4 factors made this idea stand out for us. And with that, we started working with them. And while they were going to school, after that, they were coming to VHub, okay? And it is about an hour drive. So they made sure that after school was done, they spoke to their principal with their teacher. So the school supported them. And more than 3 times a week, they used to come here along with the principal and the faculty. And we actually helped them create a business plan. And with that, they started, I think, around May 2023. And in November 2023, they actually not just grounded a company, they also received a seed investment of 8 lakh rupees. Mind you, these are kids from 8th and 9th grade. But they actually could also not just ground a company, they also received seed funding. They were also making revenue. And in this entire process, they also trained about 543 government school kids from around their school's area. The reason I'm telling you this is when we talk about innovation, when we talk about entrepreneurship, we look at it as very isolated from the day-to-day life that we live. It is not the truth. So to be innovative and entrepreneurial, you don't have to choose that, this is my real life, this is how I'll be doing my thing, and this is going to be something that is going to be added on top of it. It doesn't work like that. If you want to be an innovator, if you want to be an entrepreneur, it cannot be an activity that you do in your spare time, right? You can think about it in your spare time, but when you want to do entrepreneurship, you cannot discard your other things, or you cannot say that, I will do one or the other. It's not going to work. If you want to become an entrepreneur, you need to make sure that, you are able to plan your time much, much better. You're able to make sure that, when you are trying to do something, you're scheduling yourself in such a manner that without having an impact on what you're already doing and using the academic rigor that you have as a springboard for what you want to achieve, that is the one which yields the most results. The second thing, again, which is very, very important is that, when you do, you also need to plan out that, okay, I'm doing, botany this year. Next year, because, the college I want to apply or the course I want to take needs me to do something else. So I'll go off to a completely different career, academic program or a different certificate. It's not going to work because as you go on, it is very important to become a subject matter expert in something. If you try to spread yourself too thin by trying to do too many things, you'll become a person who has an insight, who has an awareness about a lot of things, but not a lot of in-depth knowledge in anything. So you need to make sure that when you're planning what you how you want to do, partake in learning something new. How is it complementing, or how is it actually feeding in somewhere into what you are going to do next? I know for kids it might look like, oh my God, it seems like a lot of work, but it is actually quite simple. So I was at a commencement speech by Steve Jobs in 2008. I think about 14 of my friends were graduating from Stanford at that point. And I would encourage all of you to highly, pay attention to the speech itself. It's on YouTube. So one of the things he started out by saying that Steve Jobs, the founder of Apple, he started out by saying that, I enrolled in a college, but I did not have an interest in what I was studying. So I actually went to a calligraphy class. Then I went to a design class. Then I went to some other class. I audited several other classes. I also learned languages. He told us all this, and we were in Stanford. We were just sitting down, and we were like, why is he telling us all this? But when he actually finished his past story, and then he told us as he went along how when they were designing the font for the Mac OS, how his calligraphy skills actually came about, how he actually put them to use. When he was designing the UI, how his design classes that he had audited way back in college actually helped out. It also he also spoke about when he was also trying to do different kind of user experiences, how his language classes helped him get the sensitivity and the understanding of how he needs to approach different kind of target segments. So all I would like to say or tell you guys is that when you want to be an entrepreneur, or when you want to even pursue or try out entrepreneurship, the first thing is to get started with all the skills you have and not treat entrepreneurship as something on the side. It has to be part of you. The second important thing is, when you are innovative, it is not an innovation unless you translate into an actionable outcome. So you need to make sure that any innovative idea needs perseverance, research to become an innovation. And the third important thing is that you're all kids, so make sure that you're enjoying and keeping the curiosity alive. And last and most important thing, if you do want to pursue any kind of an entrepreneurial idea, make sure we will always support you. And the initiative that is happening here, the hackathon that you guys are going to be part of, it is quite important that you get all the technical support that you need and the mentoring support that you need, not just to win this hackathon, but also make sure that you are able to create something which is going to make a difference, either in the technical aspect of India or in the social aspect of the country. So with that, I'd like to say thank you so much for the opportunity, and I look forward to hearing and learning more about the hackathon as it goes along. Thanks.
Thank you so much, ma'am, for your encapsulating talk on innovation. Again, I say if there are any queries from the student side, we'll get back in touch with all the speakers of the day.
Thank you so much.
To conclude the session, we would like to invite Dr. Somdatta to deliver the vote of thanks to our respected speakers. Ma'am.
Thank you very much, Raina. And I must thank all the speakers today, Dr. Pankaj Dhaka, Dr. Pavitra Nayak, and Ms. Dipti Ravula, who brought in so much expertise with them to tell us about the different facets of the two thematic areas that Epic Hackathon is focusing on this year, One Health as well as energy. And I hope that their talks helped our students understand health from the perspective of the entire environment. Very often we tend to think about health as only as human health, but it's important to acknowledge that health is not just meant for humans, but for plants, animals, and together, health of all different living organisms impact each other, and that's what really One Health is. And we hope that in the coming month, we will see ideas from students on how do they think about health, and by health I mean diseases here, because that's what the hackathon is looking at. How can students come up with ideas that can look for prevalence of different diseases? How do you collect those data? Or how do you think about diagnosing, how going about creating newer tools for diagnosis of different diseases in your communities? Or how do we go about creating a warning system? Can you figure out the disease is coming before it really comes full-fledged? Or how do you help people manage diseases? Can you come up with ideas that work for your surroundings, for your communities? Similar for clean and green energy. Pavitra today talked about his work and their lab's work in solar energy, which is definitely one of the very, very well discussed energy modalities that India is also looking at. So I hope that that talk also inspired you to think about how we need to build tools to capture energy better and store energy better. So that there are these different aspects of, first you capture the energy, then you store the energy, then you utilize the energy efficiently. And I hope that the talk also inspired students to think about ideas of how they might want to participate in any of these three parts of energy usage in their own communities. And Deepthi Ragula's talk on and discussion and deliberation on innovation was really cool because she talked about the importance of interdisciplinarity that's required in innovation. Innovation is not something that you do just for certificate or not just something that you do for one time's sake. It's really a mindset. And it was extremely important for us to acknowledge that innovation today, while we talk about it very, very lightly, very often, it is important to know that interdisciplinary innovation really requires us to be serious about it, to persevere about what question do we really want to solve and how do we go about solving it. And while it's not an easy task, it requires mentoring and it requires us to develop diverse skill sets. And today, luckily, there are mechanisms for these available. There are multiple forums such as VHub, as Ms. Ragula herself said, that they have mentoring programs for children. And that's what many others are also trying to do. So we really hope that we put together these ecosystems and we help young people come up with solutions to some of the major problems that we are seeing. And in the process, we create innovators in the ecosystem. With that, I'll close. And Rena, over to you.
Thank you, ma'am. And before we end the session, there is a question of the student to Dr. Pavitra. Dr. Pavitra, are you here?
Yes.
Yes. So there's a student is asking, will the efficiency of a solar cell decrease if we make it in a sheet form?
In a sheet form, well, not necessarily that would decrease because the physics doesn't say that. There could be many other reasons that the thing would go down, but physics doesn't say that if you make it in a sheet form, the efficiency will go down. There is no reason, but there could be many other reasons that efficiency would go down. And one thing is that, let's say it get folded, like it's not in a proper angle to receive the sunlight, right? If it is flexible, then it can just bend, right? So then you don't capture all the sunlight. So this might be a problem. But there are like other applications. Let's say you want to put an irregular shape of the surface, then it's one of the best way to do that. So
okay. So I hope the query of the student is answered. Thank you so much, sir. In case we have other queries, we will get back in touch with all the speakers today. Thank you so much for your time and efforts. Thank you so much.